We only need the decisions. We don't need the play-by-play. Yeah, right. The guy that wrote the protocol is going to take the minutes. Thanks, Richard. You want to start? You want to do that?
Okay, hello everybody. This is MLS. MSL here on the on the slide.
For the fail, just saying if you're paying attention.
This is the note well. Please read it online if you haven't. If you've been to any session, you've probably seen it. Here are some meeting tips. So if you're in here, we have a QR code. Scan it. This shows that you're here, and make sure we have a room that fits everyone next time. With that, this is going to be a pretty packed schedule, lots of technical things. And this is graffiti, you know, the MLS after the protocol RFC has been out. It's, you know, it's getting the word around with the street team again, apparently.
So apparently the story was, I think somebody took this that's in this room, but it turned out it was on the bus line where Benjamin Berdouche, and he uses that like bus line every day. So we thought this was very apropos.
Okay, so we have a full agenda. Let's move on to, here at Administrivia. So these are the talks. We're going to have time for questions for each of these. And there may be some additional changes. We've already had one agenda bash. Is there any other changes that people would like to request?
So yeah, my only request would be that I maybe not last. If I could move one up, that would be
It's great that
fantastic.
the people that were right before you asked to move back in the line, so that might work out so that you're not absolutely last. Okay, cool, great. So the grand announcement at this meeting before we start is that our RFC is actually published, 9420. Richard will pass out some champagne. Hard to take minutes. I appreciate that. Would you like to last? Cheers, cheers, cheers. Thank you very much. Thank you very much. And I guess the other document that's in process is the architecture document, and Eric has like 2 sentences to say, so we'll ask him to come up, and then we'll jump into Richard's presentation.
Yeah, so you know, we sort of looked through it and decided it needed a little more editorial work, so I've been doing some of that. There shouldn't be any really like substantive changes about like the actual technical stuff, but like I was just trying to make it more useful for people and more approachable. So we've already done about half of the changes. Feel free to look at them, you know, the new draft, and I'm going to be pounding those out in a few weeks, and then we should be done.
That's cool. Great. I appreciate it. Yeah, the next couple of weeks would be awesome. Then we can get the other one out at the door. So, Richard.
All right.
Just say next when you want to get to the next one.
Lest you may have thought that the protocol was complete as published, we need to add more stuff. Next slide, please. So we made 3 types of credential, well, 3 identifiers for credential types in the RFC. Basic credentials, which have no identity associated. X509 credentials, which are like full-up certificates, but we need more. Next slide. In fact, we need to double the size of the IANA registry.
Ooh.
So this document proposes a few new things. So user info VC is a new format for actual credentials. It's a way to issue credentials to users more easily. And then these multi and weak multi credentials are basically virtual credentials. It's a way to combine some credentials of other types so you can present multiple credentials for a single client in a single group. So I'm going to talk about each of these real quick. Next slide, please. So user info VC is probably the most interesting one. So this ties together with some work that's going on in the OpenID Foundation to make it possible for OpenID providers to issue credentials that are compatible with MLS. So OpenID is working on issuing these things, and this is the corresponding document to tie them into MLS. You may be familiar with a bunch of this stuff in this JSON object if you looked at OpenID before. So we got like names and given names and family names and email addresses, like all the stuff that you're used to authenticating with an OpenID provider. The thing that's cool and new here is this did JWK thing, which binds all of this identity stuff to a public key. So I think if you like squint your eyes real hard, the three main things in a certificate are identity stuff, a public key, and a signature. And so this is basically a JSON credential, JSON certificate-like thing that gives you those three key attributes in a way that fits better with OpenID and the way that community talks about user identity. So the idea is if you've got an SSO provider for an enterprise that's already doing OpenID, you can extend that pretty naturally to do these certificate-like things. And now with what we've defined in this document, you can pull those into MLS and have end-to-end secure communications authenticated by your enterprise SSO provider. So like if you're having a WebEx meeting that's using MLS and you're presenting these credentials, you know that WebEx isn't impersonating you because the other side, because you're hearing directly from the other side's enterprise SSO provider. So that's the pitch here. It's kind of notching together with some stuff from OpenID. Next slide, please. Now, as we start, as folks have started looking at implementing, these identity schemes in reality, both traditional certificate-based stuff and these new user info ones, there are some cases where you might want to present multiple credentials for the same client in a given session. So if you're a messaging provider, you might want to say, have one certificate from the messaging provider that says, this user has this handle in the messaging system, but also provide a user info VC credential that says the SSO provider says the person has this email address. And so you get attributes both from the messaging provider and from the SSO provider, and both of those tie together. So what these multi-credential schemes do is say you have a credential of a given type that binds to a signature key. And then these signature keys that go with the credentials all bless the single signature key that is going to represent the client in the MLS group. So, I mean, it all kind of fits together in the straightforward way. Each multi-credential is a collection of credential bindings, which have the credential, the signature key, and the signature over the leaf key. Kind of as you'd expect such a combiner to fit together. The slightly interesting bit here is the multi versus weak multi distinction, because there's a couple of different use cases here. So if you, in this case where I was talking about where like you want to present a provider level identity and an SSO level identity, you probably want everyone in the group to understand both of those credentials. And so they get all of that information, understand all that information. So that's what multi-credential does. So everyone in the group has to support all of the credential types in the multi-credential. Because in MLS, we try and make sure everyone can process all the credentials. We have uniform credential support. So we continue that uniform support everything scheme with the multi-credentials. These weak multi-credentials loosen that a little bit. And so this is to allow for like transition scenarios where maybe I'm trying to introduce a new credential type into my system. And so everyone starts out supporting the old ones. Maybe like half the group now has upgraded and they support the new format. And so this weak multi-format allows me to present old and new credentials. And as long as everyone in the group supports one of those two, it's okay. So really the only difference between these two, all the processing works the same. The only difference is how we evaluate these support requirements when we're adding folks to the group or adding credentials to the group. And I think that's it. Next slide, please. I think a couple of folks have taken a look at this. It says draft 00, but it's really kind of a draft 01 because we did another one for the last IETF. We just renamed it. We've got a draft implementation in MLSPP. We're working with some OpenID providers to prototype out the OpenID end of this so we can flow it all the way through. Yeah, I'd love to get an adoption call and any other expressions of interest in folks who are interested in the draft as it is, or other types of credentials that people are interested in. Since we've rebranded to additional credentials, we now have kind of a bucket of a draft. So if there's like fancy moonshot credentials that people like, we could in principle add those here too if there's momentum. That's all I got. Cheers.
Yeah, Rafa Robert speaking. So I haven't read everything in detail, but I think in general this is something that we need. So we need fundamentally this dissociation of a very long-term identity of a user with something that you use with MLS, simply because you want to rotate that more frequently. This is good for FS and PCS for the actual signature key. There's some very practical aspects, like, for example, having the long-term certificate in a secure enclave in a phone that is secure, but that you cannot always access when you need it to send an MLS message. So this layer of indirection is important there. And generally supported, we've also seen that with the reduced metadata, for example, it's useful there to have one more layer of indirection, for example. So yeah, fundamentally, without acknowledging all the specifics here, I think we should have that. So I'm expressing some interest here. Yeah.
Great. Rohan?
Hi. Yeah. This is super useful. Good work. I been following this for at least 9 months now, and this is finally starting to cover all the major issues. So I think it's ready for adoption, and I will I'm willing to do document reviews and implementation.
Daniel Cohen Gilmore. I also support this work. I think it's good to exercise some of the extension points that we have this early on. I think that's good. Raphael, I just want to try to understand. You said that you thought this was useful, that the decoupling of long-term identity from MLS keys is good for, you said FS and I think PFS, which to my mind is forward secrecy, but I didn't think these were secrecy keys.
No, they're not.
So are we actually using... Well, the private keys are secret, but I thought that the key schedule was not related. If any of these keys are lost, I didn't think that they would break the confidentiality of the messages. So maybe I'm misunderstanding something, which is entirely possible. Or
No, you're correct. Like the loss of these private keys would violate authenticity. So,
but not confidentiality.
right.
Okay, I just wanted to confirm that I hadn't missed a big page of what's happening in MLS here.
Yeah, just to rephrase what I think Raphael was hitting on. I've shown this example structure here with 3 different credentials, but you could actually have a degenerate case where you have a multi-credential with only one credential. For example, if you have an external wallet that holds a verifiable credential, that could sign one of these credential bindings to bless an MLS key without having to be kind of pulled across into the MLS boundary. So there's kind of some utility to this indirection structure even without the multi-part.
I apologize for not having read the draft, but does this allow for indefinite recursion? What kind of headaches are we opening ourselves up to
I
here?
intended to forbid multi as one of the I forbid recursion.
Okay.
I don't know if it's in there. That's
Okay.
it's a good thing we should make sure to get. Yeah.
So FS and PCS, I didn't mean that regarding MLS, literally the key material, the signing key material. So for example, you have a long-term credential in a secure enclave. You have a short-term signature key that you use all the time for MLS. Your phone gets compromised. That short-term signature key gets compromised. However, you can issue a new one that is signed by the one that is in the secure enclave. So the damage is not too bad. That's what I mean. No, that would be PCS, I think, in that case. Yes.
Yeah.
Rio Kasawara speaking. I generally like the idea about using user info VC, and I wanted to ask about the multi and weak multi credentials thing. I think these are like a meta version of the credential types compared to like user info VC and X509. So like I wanted to ask why did you choose to like include this at this layer instead of doing a separate draft, because like this may result in like as someone said like infinite recursion.
Yeah, I'm hopeful we can avoid the infinite recursion just simply by forbidding multi-credentials as a credential type in a multi-credential.
Okay, yeah.
Yeah, and so yeah, I put them in one draft just because they were more credential types and it saved a little bit of text. But if folks think they should be split out, I'm happy to do that as well.
Okay, thank you.
All right, so we're going to run a show of hands to see if we should do an adoption. So I'm going to start one in a second. So hopefully you've logged in and you are able to participate. Here we go.
I can't get it. I'm raising my hand. Sean.
Yeah, chairs. All right, well, it's unanimous at this point.
Excellent.
So we'll call that done. Thank you, Richard.
All right, thank you.
And again, it's always a starting point, so the draft can get adopted and then get waxed. So yeah, it's typical. All right, so next we have Rowan. Do you want me to do it or are you going to do it?
Please run the slides for me.
Okay. And I'm going to take you up on your offer to do an abbreviated presentation.
Okay. So next slide. Hi, it's me.
You're fast, man.
So, the two drafts that I most want to talk about are this, the draft that is on this slide, and then one on the next slide, which is the self-remove proposal draft. So, what is this? This is a quick and dirty cipher suite using an already defined, already IANA registered key exchange mechanism. So this is a hybrid post-quantum Kyber and traditional X25519 key exchange mechanism that instead of doing the default cipher suite, instead of doing a Diffie-Hellman chem using X25519, we do it with this hybrid post-quantum traditional chem. Why is this important? This protects from the harvest now, encrypt later attack. This category of replacing the chems replaces from this category of attacks where somebody can go and download traffic and then decrypt the traffic later, even, could be 10 years later, and that traffic might still be relevant. So this is super straightforward to plug into MLS. It's actually quite fast. This was roughly 2.5 times slower than just doing X25519 alone in our implementation. It's big, but it works. It's implemented. It's super straightforward. Now, is this like the end all be all of post-quantum in MLS? Absolutely not. So there are several cipher suites which could be coming. We could have a much more generic approach to how we're going to deal with post-quantum. First of all, Kyber is not yet standardized. It's probably going to be another year before NIST finishes the process. And so there will be a new version of this thing, which is now Kyber with some small changes. There will be post-quantum only versus hybrid key exchange mechanisms. There'll be hybrid approaches which mix versus concatenate. There will be the desire to do post-quantum signatures or post-quantum and traditional signatures. And there will be other post-quantum approaches which require MLS extensions. So I know that Joel, for example, and Britta have a mechanism that they've been looking at that could really solve the size problem, but requires some more substantial changes to MLS. So I think this gives people the opportunity to go and implement something soon that can solve an immediate problem or let people get some experience with a new chem. It's easy, and I would really like if we could move forward with this and not wait for like the ultimate, here is like a post-quantum framework for MLS. And I also support that work as well. Okay, thoughts, Raphael?
Yeah, I think it's great. I think we need it, on principle, because we've been working on MLS for the past 5 years. We've always said MLS is post-quantum ready. We cannot keep saying, in theory, it's post-quantum ready, but, we don't know what we're going to do exactly. So that's why we need this. A couple of remarks. I think the attack is called Harvest Now, Decrypt Later.
Indeed. I noticed that.
Unless you know something we don't know. And so specifically for that attack, this is much more than we need for that attack. What you already alluded to, that there could be a much more lightweight version of doing that, because this gives us, full FS and PCS on a post-quantum level that we don't need specifically for that attack. So but as you also said, we can solve that later, and folks are already working on that. So yeah, I support it. I think we should do that.
Yeah, Richard Barnes, Raphael, the encrypt later attack is the latest ransomware technique. Yeah. So Richard Barnes, I also support this work. I think it's really nice too that we sowed our quantum support by post-quantum support by relying on chem. So it's nice to finally reap that now that we've got the protocol ready to go. The only thing I noticed that we should probably get tuned up is that the symmetric bits are AES-128 and SHA-256. I think they should probably be bumped up to the larger sizes.
Yeah, so I also questioned that, and then Bas Westerban told me that I was wrong, and that AES-128 is good enough because it's unlikely to be subject to the Grover thing, because it cannot be parallelized well. So the security level is low, but if you cannot parallelize stuff, it's good enough. So it's very unlikely that that will become a problem in practice, and a lot of other things are much more likely to happen. So apparently there is some consensus, or it's a bit of an urban legend that you absolutely need AES-256.
Also,
for optics, it might still be a good thing to do, maybe, but yeah.
Yeah. Also, what I'd heard was that the reason for Kyber 768 instead of 512 was to get up to so that it was above the 128 or at or above the 128 level.
Okay. Yeah, and this may be something just to get a few folks to look at who are in the space, in addition to Bas. The cost of upgrading seems pretty low, so it may just be conservative. But yeah, we should get advice on it.
Okay.
Britta Hale. I also hardly support this draft. Rowan mentioned that there is ongoing work for another version of hybrid. It is intrinsically different use cases, so they're not in competition at all. And definitely think this is a good way to go.
Hi, Michael B, UK NCSC. On the AES-256 versus 128, we're using X25519 here. That's roughly equivalent to AES-128. So let's be consistent and stick with that, or go larger on the chems if you want that. The other thing is, thank you for using the terminology of my colleague in her draft. I'm sure she'll be very grateful.
You can thank Paul Hoffman for that. Uri?
Considering that pretty much everywhere, including microprocessors, AES-256 is accelerated, hardware accelerated, regardless of how expensive a Grover's algorithm is going to be in practice. Who cares? It's not that expensive to just use AES-256 and not worry. This standard requires AES-256, that one requires AES-128, that obscure one wants AES-192. There is a reason why CNSA 2.0 settled only on AES-256 for everything. It's simpler.
Uri, do you support the draft moving forward with or without as AES-256 or 128?
Yes,
whichever one gets
and
chosen?
I'm for moving this draft forward. I prefer to keep AES-256
Great.
out.
Yeah, I think keeping the alignment of security across the symmetric, asymmetric aside, we're going to do a call to whether or not this is something that the group is interested in adopting.
Should chairs issue a working protocol? No.
Call for adoption is always on the list.
There are more for this one. I'm going to end it.
Yep.
It's unanimous.
Okay, next
Okay, we'll
slide,
take
please.
this and the previous one to the list. Thanks, Ron.
All right, next slide, because there was another one on there. The self-remove.
One more.
Okay, so right now removes are challenging. So in groups with lots of joins and removes, it's hard to leave because external commits can invalidate remove proposals. So what we've seen in our actual testing is that a client, in the absence of like a sort of a designated, leaver joiner kind of control node, clients might have to wait an undefined amount of time, which often is several epochs, like between 3 and 7 epochs, before they're able to leave, because they send a remove proposal, somebody else does an external commit to join, and another external commit to join. They might actually issue the same proposal over and over again before finally they're able to get it in and someone else is able to commit it. This is problematic because that client has access to the group keying material for the entire time that this is happening, and it's just annoying for the client that just wants to like leave the group. So the self-removal proposal type, it has one critical difference with remove, which is that external committers are required to include any pending self-remove proposals which are valid. So remove proposals are not valid inside of an external commit by spec. It only includes a null body inside of the proposal itself because the leaf index comes from the self-removes sender.leaf index. Lastly, because a sender of an external commit can't validate the membership tag, it skips this validation. And in the security considerations section, it describes why this is no worse than the status quo with group infos, which it also cannot validate in exactly this same narrow manner. So I received a handful of comments on the list after I submitted this. Those have all been addressed in the editor's copy on the GitHub repo there. So in terms of next steps, this was discussed among a handful of people already, and it's been, there's been some comment. Is this something that we could move, for example, into the extensions draft? What would folks like to do with this?
Yeah, just so to reiterate what you said so that you also hear it from somebody else, we discussed that intensively among quite a few people. It's always a trade-off, no matter how you design this, and I think this is probably the best trade-off. The damage that can be done here is also very limited because the only attack could be that the attacker removes themselves from the group. So it could be a lot worse. So I think we should move this forward, and I also think that the extensions document is a natural choice for that because I think the description is relatively short, and it's a very essential thing. And to a degree, I am to blame here because I was the one who proposed the external commits that introduced the problem in the first place. So yeah, thank you for fixing that, Ron.
Hi, Joe Hall from Internet Society, although I'm not here. I'm here as an individual. It seems like having access to the keying materials isn't such a big problem. The client could suppress for the user experience of continuing to receive messages. But is the trick that you'll have to have sort of the time will be a while. You'll see like a spinny thing or whatever until you actually remove, or is there a deeper problem than that?
First of all, it's annoying for the clients and indeterminate because you just don't know how many, there's no limit to how long you might have to wait. And particularly if that client is a mobile client and it's like near the end of its battery and, it's like, it might wish to be removed and it might not be able to do that in a finite, tangible amount of time.
Okay. Thank you.
Okay, I guess we can do a show of hands for like put the proposal in the extensions draft, but if nobody's getting up to speak against it, that seems a little like overweight. Just submit a PR and let's get on with it. All right. Does that work for you, Rowan?
Works for me.
Cool. Thanks.
Thanks. Take care.
All right. Okay. Cool. I'll stop sharing those slides. Go back over here. we're going to move on to your slides. Be prepared for the orange.
I was inspired by Richard regarding the color. All right, yeah, so I'm not going to propose anything for adoption today, just talk about the MLS extensions, give folks a little update on that. Next slide, please. So as you know, we have this extensions document that has already been adopted. Can we move to the next? Sorry.
1 second, operator error.
Yeah, so what we've been working on in the past months, although it was a relatively low-key effort, was to see if we can actually give some guidance as how to design new extensions in a safe manner. So the idea here is to give guidance in that document on how to do it, to include a concrete API to the extension, and then also give some examples. That's still work in progress. It's not there yet. It's happening now. Next slide, please. So these are the extensions we currently have. AppAC, it used to be in the core protocol. It moved out of there. Targeted messages is something where you can send a message to just one member in the group. And content advertisement, that happened in the realm of Mimi, and there's going to be more of that. Next slide, please. So yeah, the idea behind the safe API for the extensions is that you can design an extension that is not going to interfere with the core protocol, but also not with other safe extensions, so that you don't have to coordinate with all the authors of all the other extensions. So it provides a safe way to, using or extracting key material, for example, and then, using labels, etc., to disambiguate the key material and to have domain separation. So new PSK types for the injection of key material, etc., exporting extension-specific secrets, and stuff like that. Yeah. Next slide, please. Also guidance on how to use VAAD. This is currently coming up for Mimi. Also, yeah, regarding proposals, inclusion of paths versus not including it, and using it with external commits where the logic might be a bit different. Next slide, please. So yeah, there's been a lot of discussion on extensions we could do and we will probably do. So none of these are really proposed yet, and not necessarily all of them will go into the document. We have to see that. The question comes up regularly about deniability. As we all know, it didn't make it into the core protocol because there was not enough traction for it. We've been working, again, it was a low-key effort, on two modes of deniability. One relatively straightforward one where we can have deniable application messages but not deniable group membership, and then a more comprehensive mode that we only started to look into recently, where essentially even the group membership would be deniable. We have something there. We are not really satisfied with the performance of that, so this is work in progress. And yeah, if folks are super keen on deniability and want to see this move faster, please reach out. It would be interesting to see. Then we will have a bunch of Mimi-related extensions as Mimi progresses. So the idea is that in the Mimi working group, we cannot really define extensions of MLS, so we need to do that in this working group. We discussed an RBAC extension that will have some overlap with Mimi, so we need to see what happens with that. We discussed application messages from external senders, so what that means is yeah, folks external to the group can actually send information into the group. We currently have group context extensions in the core protocol, and they're in clear text. It might be interesting in some applications to also encrypt that. That could be another extension. We already mentioned earlier the post-quantum optimized mode. Unsigned application messages are of interest apparently when the only thing that matters in terms of authentication is that a member is a member of the group, but it doesn't matter who the member is exactly. And one thing that came up recently is in the core protocol, we talk about last resort key packages, which are key packages that you don't throw away because it's your last key package. You need to keep that around. it would be interesting to mark it as such so that we can handle them better. And potentially more. So if anyone is interested in any of these topics, there are different people working on it. Please reach out and then connect that. None of it has really been brought to the list yet because it's an early effort still. Next slide.
That's it.
I think that's it. Okay,
So
good.
I guess as a chair of a working group that recently got done with a protocol that in the version got rid of a bunch of old extensions, I would just like to apply the restraint where possible, if you can not just go hog wild, because if we have version 2 to like blow away half of these, that would not be awesome, I guess. The other thing I think we might be talking about later, if we have time, is the interaction with Mimi. It's not entirely true like for TLS, right? Other working groups can actually define TLS extensions, but that didn't happen for years because we wouldn't let them. And so maybe because this is a new protocol, they need to come back here because all the people who did it are here still. So maybe that's something
right
we
now
can
the
do.
charter of Mimi forbids
Okay, all right. Well,
to
that
do
makes it
that.
even better.
So we would have to recharter from Mimi.
Okay,
Yeah.
all right.
But yeah.
All right, cool. My connection is failing, so I'm going to reconnect, and then we're going to have Britta come up.
Cool. Thank you.
Apologies. All right. Sorry, Britta. If you can get in and or if you can do it from your phone, that's all well good. But I'm out. Yeah, like share the slides. Oh no, it's trying to do something now. I ought to be able to do this. No, chat room, full client. Oh, it's coming back. Sorry. Apologies. We even look like we're going to have time. Oh, here we go. Come on. Yes, request browser permissions. Give away my permissions. Hit slides. Go guardianship share.
Cool.
All right, cool.
All right. Hey, good afternoon, everyone. I'm Season Tan. I'm presenting some joint work with Dr. Hale and Elsie Fonovic. Next slide. So we're presenting this idea of guardianship for MLS. It's for use case where users with multiple devices operating in limited mode or receive only mode still want to have some nice security guarantees that MLS offers. So some general cases may be some traveling user who has limited bandwidth, or remote IoT devices that have periodic connectivity, or maybe even wearable devices that are in receive only mode necessarily. So getting to this concept of guardianship, it's basically where you have a designated guardian device performing updates on behalf of a edge device, which is the device that's in that receive only mode or limited mode. And so with this kind of concept, you have improved forward secrecy in that the guardian's periodic updates allow the edge to be to have smaller security windows. And then with post-compromise security, as it currently is in MLS, you have to perform an honest update after you're compromised to self-heal. So this guardianship PCS concept is that the guardian will be able to perform key updates on behalf of a paired edge to heal. Now, this does require some kind of pairing or key sharing in between the guardian and the edge ahead of time, but we'll explore those in our constructions. All right, next slide. So before diving into the constructions too much, just wanted to share some of the design decisions that we ran through in kind of designing out the constructions. So we have first a shared leaf. So this is where you either have the guardian and the edge share an MLS leaf, or they're distinct leafs. Specifically in the construction that we have, they're going to be sibling nodes. You have a shared signature. So this is the signing key, and whether or not guardian or an edge can share a single signing key, or they have to have distinct ones. And then shared randomness. So this is ultimately going to allow the performance of updates. All right, next slide. All right, so these are the shortlisted constructions that we came up with. And so they range from kind of a naive implementation of just doing guardian edges in the existing MLS construct, except that you require them to be sibling nodes so that they have that shared path to the root. Or you have the case of forwarding, where you have a guardian as a member of the MLS group, but you have the edge being in a separate channel with that and having the guardian forward all the control and application messages. There's also the third and fourth cases here, which kind of get interesting in that you're now talking about them sharing a leaf node and whether or not they're allowed to have that shared signing key or not. And so this kind of gets into construction 3, 4, 5, and 6. 5 and 6 mirror these 3 and 4 in that shared secret amongst them is going to be either pre-installed somehow or in a shared and separate channel. And so you can imagine 5 and 6 will have a dotted line between the guardian and the edges. All right, next slide. So with these various types of constructions, you get some nice security features centered on extensibility, whether or not either of them can be online, offline. So having this toggleable mode, traceability and impersonation, and then forward secrecy and post-compromise security. So depending on which one you go with, which construction go with, there are these various trade-offs. And we definitely don't recommend, for example, construction number 2, that forwarding case, if you're going to go about exploring that. And it's just that because you have that external channel between the forwarder and the edge, you lose a lot of good security guarantees. So ultimately, we wanted to see if the larger group is interested in this use case where we have many devices that need to be offline or in receive only mode or limited mode, and having the MLS construct support this. So barring that, that's the end of the brief. I can take any questions.
All right. Oh, all right.
Daniel Cohn-Gilmore, thanks for presenting this. I like the systemic way that you're looking at the problem. What I don't see here is a mention about the visibility to the outside parties about what kind of devices or how many devices a person has. Is that, I'm sorry, that's not one of these items that one of the rows on your table here, right?
So that's kind of getting at the traceability of guardianship.
Can you go back to the construction slide?
Sure.
Sorry, I just want to see that. So, yeah, maybe can you talk a little bit more about what you mean by traceability of guardianship? Like,
Yeah. So well, we get to that through having the identity keys being shared or not.
Okay.
So if you do share identity keys, you really can't tell if there's a misbehaving edge or if it's the guardian misbehaving. But ultimately, you can still tell that it's that particular node misbehaving.
Right. The parties who are not the ones who are setting up this guardian edge relationship, right?
Yeah, parties who are not, they'd be able to trace it back to that specific node since it's still a leaf node in the MLS tree. But if you have the case, for example, where in case 4, construction 4 here, where they have separate signing keys, you'll be able to trace back which one was the misbehaving one. And that also depends on the kind of distribution service you implement.
Right. So I'm imagining the sort of situation where the adversary wants to know when someone has gotten home and switched over to using their client on the client that they have at home as opposed to the client that they carry with them when they're walking around. Right. I want to know when they're home. I want to know when they're not home so that I can go break into their house or target them because they are home. One of those. Right. And I wouldn't want the MLS metadata to reveal which client the target is using at a different time. So if we look at the table, sorry,
next
back to
table.
the table slide. Sorry, Sean, I know you're
That's
having
all right.
networking problems.
I
and
feel
like,
I'm in this presentation now, so let's go.
Where does that? I'm sorry, I haven't read enough of your work to know where would that kind of visibility show up in this table, and how does it apply to across these different constructions that you have?
Yeah, so across all the constructions, we have the ability to do a toggle online offline mode. And so depending on, so what you're getting at is true, like if your distribution service somehow is hacked by the adversary, then depending on which construction you have, whether or not you do the shared signature or not, they may be able to tell when you've come online or offline.
Is it just the distribution service that's a potential adversary here, or anyone in the chat as well?
I'll have to let, it looks like
Okay,
Britta's
sorry, I'm
anxious.
I'll just jump in there. Great question. So when we talk about the traceability, and obviously Susan's giving a short version of this. Traceability, if it shows green, then it could, thanks. If the traceability shows green, then the other devices could potentially see. And if it's like full green there, then yeah, they can see it. If it's partial green, then it really depends on the distribution service. So what you're getting at is really, is it a bug or is it a feature question? Because sometimes it's actually good that the other devices, assuming that we are all doing this sort of mode, that we want to know that I don't have like some, parallel device sitting in and listening to the conversation. That's really your main edge, right? And then there's a version of, I actually don't want other members to know when I'm shifting between devices. So yeah, basically it's kind of like, depends on which use case you want to aim for. And that's why what students presenting here is saying, what is the group interested in? Or are we interested in this sort of offline? And it's not a true offline mode, I'll say that. It's if I'm in receive only mode, so I want to be getting in messages. But I want some sort of updating to happen so I can get those security guarantees. Are people interested in it? And which sort of things are concerning? Because there's clearly trade-offs between those.
Okay, thank you. I need to think more about the different trade-offs here, but I appreciate the details.
Hey, Richard Barnes. Yeah, thanks for this presentation. It's interesting to consider some new properties here. It seems like something that could be useful. I was wondering if you had kind of drilled into kind of what the protocol implications would be of some of these different proposals. Are these things that would require MLS to operate differently, say for a commit to have a different shape, or are these things where the Guardian might attach something, staple something to the side of an MLS message that gets read by the edge node, and so it could be done kind of outside of MLS?
We didn't look at it specifically in terms of like what the commit messages would look like for this. We analyzed it from just in general, a continuous group key agreement protocol would need to do in order to accommodate this. I'll let Britta answer again.
Sorry to jump in. So to answer your question, for most of these, nothing would have to change. The MLS protocol is treated as a black box. So the couple right at the end, it would depend on, will we allow multiple signature schemes per leaf node? So that would be the main change. Most of the rest doesn't get changed, and it would be external.
There may be then some overlap with the multi-credential stuff from earlier. Okay.
That is draining the queue, and we have 10 minutes left. Any other questions?
Okay, so I'll be last. Palo Alto's 80. Sorry, not questions for this. Sorry, you meant?
No, so I have a question about this in
Oh,
general.
okay, sorry.
Yeah, so I mean, like, so what's the plan next? If there's like not go away, I didn't hear anybody say go away. I got to think about this a little bit. The next step is to,
Yeah, we could work on a draft.
yeah.
Yeah, it sounds like so the main goal is to see if there's interest, and it sounds like there's a couple
Yep.
points of interest, particularly with like multi-site
Yep.
suites and stuff. And then those people would then hopefully get together and write up a draft and bring it back and see what people think of that.
All right.
Awesome.
It looks like this is maybe sampled from a bigger write-up. Has that been sent out to the mailing lists? Okay. Yeah, I would be interested to kind of understand like the deeper detail here.
Yeah, and we have a paper that's in review, and we'll have it out in ePrint soon.
Great, cool, thanks.
Yeah.
Cool. So I guess the summary is we'll write an ID, internet draft. Awesome, great. And Paul, you get the final word. If this is the whole session, or is this going to be like, if you want a session next time, make sure you send it on time and get the room appropriately sized? Because by the way, that was all my fault. So yeah.
Okay, well,
I learned some lessons on that.
No, there's no. I'm not saying that any of the work that is proposed today is not in charter, but nothing is in charter. So we need to recharter. So let's take an action item for the chairs and me to recharter and And then the working group has to figure out what to prioritize and to set some milestones. So maybe have that discussion.
I can do that. That sounds like a plan. That's a fair comment. And with that note, I think we're going to call it a day. All right. Going once, going twice. Thank you. Thank you for taking notes, Richard. So, I'm now of the firm opinion that
quick one was hearing some questions from IoT folks that I showed them MLS. So I think I remember when I talked to Joel.